Good morning.
Good morning. Good morning.
All right, so who do we have missing in Holbrook?
Cabri.
Who?
Cabri.
Cambry?
I tried over the weekend.
It's Cabri.
Anybody else? Who we missing there in the second
Caitlin?
one?
No, Caitlin.
Caitlin?
Yeah.
All right. All right, and then we're missing Jill. Is that it in Joe City? Okay. All right, so today we're going to finish up 7:4, chapter 7. Also, we're going to start in on 8:1, I think. But before we do that, I do want to just talk for a minute about next week. Well, okay, this week we're going to do quizzes 7.3 and 7.4. And then also this week, Joseph City's going to do 7.2. Then we have next week we're going to do, I'm probably going to have a Moodle day. Either Monday or Tuesday next week. I'm thinking about Monday so that we can get in the chapter 7 test. And then we're going to do the midterm next week. So I'm thinking the chapter 7 test on Monday of next week. And then we'll probably do the midterm on Wednesday and Thursday of next week. So it's 2 parts. Each part is 1 hour. Each part, you just have 1 attempt. So it's not like the quizzes or tests where you get 2 attempts. You just get 1 attempt on each part. We take the average of the 2 parts, and that's your midterm grade, which accounts for 20% of your overall grade. Okay? So that's going to be next week.
Mr. Strong?
Yes.
So the 7.2 quiz we took on Friday, it looked a lot like the 7.1 notes, and it had nothing from the 7.2 notes.
All right, I'll be happy to take a look at that.
Okay.
Some of the notes, some of the questions, if from the 7.2 build on the stuff from 7.1. So if you look at maybe the homework problems, and you might see that a lot of them are very similar. But anyway, I'll take a look in case there's a problem with it. Okay. Let's see. The other thing. Okay. So then the following week, spring break, March 16th through the 20th. So MPC is adjusted. The spring break now is going to be that week. So it's the same week as you guys have. So that's kind of nice, where we don't have to worry about missing anything. Okay. All right. So any other issues other than the 7.2 quiz? All right. Well, let's take a look at.
So, Wednesday I might be getting checked out. So, wait, no. Okay, never mind. The midterms next week. Okay.
Next week. Now, this Wednesday, if you're getting checked out and you miss those 2 quizzes, okay, let me remind you that once we take the midterm, everything at that point has to be made up. So if you happen to be missing those quizzes, and I would suggest you try to make them up on Friday or something like that if you miss them this Wednesday. But when we finish that midterm, everything in chapter 6 and 7 is in cement. Okay? So I won't be opening up anything after the midterm. So you've got basically 2 weeks to, if you still need that second attempt on 7.1 or whatever you need, okay, just let me know. Okay? Any other concerns? Okay. Well, let's get back to, 7.4. We were So we're in the second column, about a third the way down. Okay. Oh, oops. Okay, so to solve an equation in which two or more trigonometric functions occur, you rewrite in terms of one trig function. So you've got to use some kind of trig identity. The Pythagorean identities are very commonly used in this case, or the reciprocal identities, something to rewrite it so that you just have it in terms of one trig function. All right, so an example here. So this, we have cosine squared and sine in the same function. So would it be easier to rewrite sine in terms of cosine or cosine squared in terms of sine squared? Which would be easier? Well, there's not a identity that relates just sine and cosine together. But sine squared plus cosine squared equals 1 is the Pythagorean identity. So that one's easier to change. Cosine squared's easier to change to sine squared. Okay? So we're going to use that Pythagorean identity, solve it for cosine squared, which is 1 minus sine squared. And then I'm going to replace cosine squared with 1 minus sine squared. So now everything is in terms of sine. So now it's like the problem where we ended class with on Thursday. So now we distribute. So we get negative 2 plus 2 sine squared x plus 1 minus sine x equals 0. So I'm going to set it equal to 0 and then factor it. So let's combine like terms. So I get 2 sine squared x minus sine x minus 1 equals 0. Okay. Now to factor that, it might help to think about the algebra. If I had 2x squared minus x minus 1 equals 0, then to factor that, it would factor to 2x plus 1, x minus 1. So then I come over here and factor this to 2 sine x plus 1, sine x minus 1. So then I set each factor equal to 0 and solve. Okay, so here I'd subtract 1, add 1 over here. Okay, so sine x equals 1. So where on the unit circle is sine x equal to 1? What angle has a sine of 1?
90 degrees.
At 90 degrees. Okay, so then we come over here and sine x equals negative 1/2. So there's two places on the unit circle that have a sine of negative 1/2. What are they?
Um, 330 and 210.
Excellent. Okay, so then those are my three answers. Okay? All right, so any questions? All right, so I'll leave this up as a guide. Go ahead and try practice 1D. All right, so Avery, when you've got it.
Can I get some help there?
You
Please?
bet. You bet. So so we've got secant and tangent in this. Okay. Now we also have this Pythagorean identity which relates secant squared and tangent squared. Okay. So would it be easier to rewrite the secants as tangents or tangents as secants?
Secants is tangent.
Secants as tangents. Let's see what I did. I rewrote secants as tangents. Okay. It really wouldn't matter too much, but so if we replace secant squared with tangent squared x plus 1, then distribute the 3. So I get 3 tangent squared x plus 3 minus 2 tangent squared x equals 4. So now combine the like terms. 3 tangent squared minus 2 tangent squared is just tangent squared. And then 3 minus 4 is negative 1. All right, so now I add 1 to each side and then take the square root. So I'm going to get tangent x equals plus or minus the square root of 1. So plus or minus 1. So how many answers am I going to have here?
Two.
4. Because there's 2 places on the unit circle where the tangent is 1, and then there's 2 more places where the tangent is negative 1. All right, so Avery, look those up for me. So it's where the sine and cosine are the same. Well, in case of the negative, one of them is the opposite of the other.
So would it be 45 degrees, 135 degrees, 225 degrees, and 315 degrees?
That is correct, sir. Okay? Any questions? Anybody not seeing that? Okay?
Mr. Strong,
Yes.
can you explain that?
Okay, what part do you need me to explain? The substitution part or the factoring part or the square root, or where am I losing you here?
The degrees part.
Oh, the degrees part. Okay. So when you have the tangent of x equals 1 or negative 1, then you're looking on the unit circle where the sine and the cosine are the same. So at 45 degrees, for example, the cosine is radical 2 over 2, and the sine is radical 2 over 2. So when you divide, tangent is sine over cosine. So when you divide something by itself, you get 1. So the tangent is 1 there at 45 degrees. So then it's also going to be 1 down here in quadrant 3. But the sine and the cosine will be negative. But negative radical 2 over 2 divided by negative radical 2 over 2 is also 1. Okay? Then when you look up here in quadrant 2, see, then it's negative radical 2 over 2 over positive radical 2 over 2, and so the tangent would be negative 1. Same here in quadrant 4, where it's radical 2 over 2 divided by negative radical 2 over 2. And so when you divide sine divided by cosine, you'll get a negative 1 there. So those are the angles where the tangent would be 1 or negative 1. 1 in quadrant 1 and 3, negative 1 in quadrant 2 and 4. Okay, does that help?
Yeah.
Okay. Now, do you have the unit circle in front of you?
Yes.
Okay. Because that really helps if you're looking at those values there. Okay. All right, with some trigonometric equations, there is no reasonable way to find the solutions exactly, algebraically. So in those cases, you have to use a calculator. So the answer might not be on the unit circle. So usually the way that you can decipher that from the directions is that instead of saying find the exact solutions, I'll say approximate the solution. So when it says approximate the solutions, then you know you're going to use a calculator in that case. You're not going to get the exact value. So if I said approximate, okay, this is x equals sine x. See, I don't know how you could solve that for the angle. I mean, I guess I have an idea, but anyway. So what you do in this case is you could put the left, and this works whenever you have an equation. Okay, so this is a trick that you can use whenever you're stuck on any of the previous problems. This method would work. So if you ever get stuck on a quiz or a test, you don't know how to solve an equation, then you could do this trick. And the trick is this, is that you just take and you put the left side in for your y1. So you're going to have y1 equals x, and then y2 equals the right side of the equation, 2 sine x. Now, what mode do you need to be in if you're graphing trig functions?
Radian.
Radian mode. So just know that your answers here are going to be in radians. Okay? So then what you do is you graph it, and then you find the intersection of the two. Okay? So one intersection is going to be at 0, 0 here. So second calc intersect. But it intersects up here and down here. And so you'd want to find all of them. So you do second calc intersect, and so it's the x value that you're looking for. Second calc intersect up here, and it's the x value. So the negative 0 and 1.895, those are the x values that are the solution here. Okay? So see if you can do that for practice 1E. So you're going to graph it in your calculator and then do second calc intersect. And then you should, well, I don't know how many answers there are, probably 3. But so from negative pi, this one had negative pi to pi. So I set my window like that. This one, negative 2 pi to 2 pi, you need to set your window so you see all the intersections. Now, if you have any trouble setting that table up or find the intersections, let me know. All right, so Lauren, when you've got them.
I got 1.0298.
1.0298. Very good. So we only have one intersection there. Okay, so one solution. Now, the answer is in radians, so you can write the word radians. You can put the little r there, or actually, if you leave the units off, it's assumed to be radians. Okay? All right, any questions on that? All right, well, good job, Lauren. All right, care must be taken when squaring each side of a trigonometric equation to obtain a quadratic, because sometimes you get extraneous solutions. So the next algebra trick I'm going to teach you, instead of taking the square root of both sides, we're going to square both sides. But that can sometimes give you an extraneous solution. So do you remember from algebra how do you avoid getting an extraneous solution is for your final answer? You better remember what we had to do. Well, what you have to do is just check. You just check your answer. Okay? You have to plug it in. All right? Okay. All right, so here we have cosine x plus 1 equals sine x. All right, so the reason why you might think to square both sides here is because, see, again, we don't have a direct trig identity between sine and cosine, but we do between sine squared and cosine squared. So if we square both sides, then we get cosine x plus 1 squared equals sine squared x. So now multiply this out, and we get cosine squared x plus 2 cosine x plus 1 equals, now I could already see that, I could already see that there's cosines here that dominate this problem. So I went ahead and used the trig identity sine squared equals 1 minus cosine squared to put everything in terms of cosine squared and cosines. And so now it's just like before, we want to get the cosine squareds on one side. 2 cosine squared x plus 2 cosine x equals 0. Well, the factoring is much easier here. I can factor out a 2 and a cosine. I divided by 2. Because when you're factoring, instead of factoring out a constant, when you have an equation, you can divide both sides by that. And so now factor out the cosine. And so I get cosine x equals 0. So where's cosine 0?
Is it 90?
And?
270.
Have it 90 and 270. Good. And then where's cosine negative 1?
$180.
Okay, 180. So so we have 90, 270, and 180. But now, when we plug it in to the original, the 270 doesn't check. Okay, so let me just show you how it doesn't check. Let's see, do I have that on this screen or the next one? Okay. Well, let's show you that it doesn't check here. So I have, well, the cosine of 270 is 0 plus 1. The sine of 270 is negative 1. So 0 plus 1 is not equal to negative 1. So it doesn't check. Whereas the other ones, say 90, the cosine of 90 is 0 plus 1. The sine of 90 is 1. 0 plus 1 is 1. So that checks. And let's see, what's the other one? 180. Cosine of 180 is negative 1. Plus 1 is 0. The sine of 180 is 0. So 0 equals 0. So the other ones check, but so when you square both sides, that's the right way to do it, but you do have to check your answers. So the 270 doesn't check, so your only answers are 90 and 180. So 90 degrees and 180 degrees are your only answers. And so one of the bogus answers on a quiz like this would be 90, 180, and 270. So if you didn't check it, you'd get this one wrong. Okay? All right. Well, let's have you try practice 1F. It's the same idea. All right, so Sierra, when you've got it, or if you get stuck, let me know.
I got stuck on.
Okay? So when you square both sides, you get sine squared x plus 2 sine x plus 1 equals cosine squared x. Okay? Now this time, since you have sines over here, you want to rewrite cosine squared in terms of sines. And so you rewrite cosine squared as 1 minus sine squared. So then set everything equal to 0. So add sine squared, subtract 1, and you get 2 sine squared x plus 2 sine x equals 0. And then just like in the example, we can divide everything by 2. So we get sine squared x plus sine x equals 0. Okay, now we factor out a sign, and we have sine x times sine x plus 1 equals 0. Set each factor equal to 0. Now get sine x equals 0, or sine x plus 1 equals 0. So where is sine equal to 0? Sierra?
0 degrees and 180 degrees.
Good. And then here we subtract 1, and we get sine x equals negative 1. So where is the sine equal to negative 1?
$270 degrees.
Okay, so 270. Okay, so let's, we set at 0 degrees, 180 degrees, and 270 degrees. Okay, so now I want you to check those, plug back up into the original, and see if any of them or all of them check. So Sierra, when you get the final answer, let us know.
And then you plus equals.
I got 0 and 270.
0 and 270? Okay. That is correct. The 180 doesn't check. So you have to throw that one out. So your only answers are 0 and 270. Good job. Any questions on that? Okay. All right. Next, multiple angles. To solve trigonometric functions of multiple angles, so that's like if you have the sine of 3x or cosine of 2x. You isolate the trig function first. You isolate the trig function, then solve for kx, and then divide by k. equations. Okay? So let's give you an example here. All right, so what I'm saying here is the fact that we have a 3 in front of the x, don't worry about that yet. Okay? We'll worry about that. That'll worry about that the last step. So first we're going to isolate the cosine. So here we're going to add 1 and then divide by 2. So now, just like we did before, we look at the unit circle and say, okay, where is the cosine 1/2?
– 60 degrees.
60 degrees and
300.
300 degrees. So then what you do is you say then, instead of x equals, it's cosine 3x equals. So you say 3x is 60 degrees and 3x is 300 degrees. Now, finally, you take care of the 3 by dividing each side by 3, and you get x equals 20 and x equals 100. Okay? So, there is one more trick I have to explain though. But any questions up to here? Dividing by the 3. Okay, here's the trick. On these, you want all the answers between 0 and 360. Okay, now, up to this point, I haven't had you worry about the plus 360 in to get all of them. But now we need that. Okay, because, see, when we divide by 3, you divide that by 3 too. So it's 20 plus 120 in. 100 plus 120 in. So in order to get all the angles, we actually have to factor that in now too. So if I add 120 to 20, I get another answer, 140. If I add 240 to 20, I get 260. So I'm going to get 20, 140, 260, and then the next one's bigger than 360. On this one, if I take 100 plus 120, I get 220. Well, 100, 220, and then I add another 120 to it, and I get 340. The next one would be too big.
How did you get 140 again? I mean, 260, sorry.
Oh, this 260? Okay, so, well, let's back up. Okay, so you understand how I got 60, right, from the unit circle. Okay, but it's actually 60, if we wanted all of the answers for infinity, it's 60 plus multiples of 360. Okay, so then when you solve for x, you divide by 3. So 60 divided by 3 is 20. 360 divided by 3 is 120. So it's 20 plus multiples of 120. So you keep adding 120. So 20 plus 120 is 140. Plus another 120 is 260. And then the next one's too big. It's out because we want all the answers between 0 and 360. So we can stop at that point. Okay? All right? Other questions? All right, so let me leave this one up on the board, and I want you to try practice 1G. Now I'll give you a hint. If you start getting decimals, you're doing it right. All right, Kinsley, I pick you whenever you got it.
Okay.
Okay, so for the first part, I have 30 degrees and 210, and then I have 6 and 240.
Okay. So 30 and 210 and 60 and 240. That's good. Okay. So you get 30. And then you add, let's see. So you get 30 and 60. And then you're going to add 180 to those answers. Okay. All right. Any questions on that? Good job on that, Kinsley. All right. So any questions on the 30 and the 60? And then you got to add, let's see, 360 divided by 2. You got to add 180 to those answers. So that's how you get the other two. Okay. All right. Okay. Using inverse trig functions. If the answers to a trig equation are not common angles, use the inverse trig function. So inverse sine, inverse cosine, inverse tangent. So that's when you've been able to solve it. So it's not like the ones we did with graphing before. This is where you were able to solve it, but when you get to the final answer, the angle's not on there, not on the unit circle. Okay? So let's just go to this. Okay? So if we were going to solve this, what would we do? What are the steps here?
Would you add the radical 2 to isolate the sign?
Well, you're right,
No.
and you move the
Let's
signs
combine
together to combine the signs over, okay? And then you'd add the radical 2 over and divide by 3. But see, there's no angle that has a sign of radical 2 over 3 on your unit circle. So we're able to solve it just fine, okay? But we can't do the last step. We can't get the angle because it's not on there. So this is where you use the inverse sign, okay? So you'll do the inverse sign of both sides, and so that's what you put in your calculator. So go ahead and put that in. So it's like we're doing the inverse sign of the sine of x is just going to give me x, and then so I do the inverse sign of radical 2 over 3. Now, the answer, remember that the inverse sign gives us the angle. So you need to make sure you're in whatever mode you want the answer to be in. So if you're in radian mode, your answer is going to be in radians. If you're in degree mode, your answer will be in degrees. Okay? All right, so Sierra, what do you get?
Is it 28.1255?
28.126 degrees. Okay, very good. Okay, any questions on that?
So you don't do the 180N or whatever, 360N plus 360N on that?
Well, let's see. Oh, no, you only have to do that when when it's a multiple angle. Okay? Now, if we needed all of them, you're right though, because the sign is positive in quadrant 2. So if we measured 28 degrees up from 180, we would actually get this one. So we technically we should have 2 answers for this. I was thinking about application problems. When you're doing an application problem, you typically just work with the first interval, so in the first quadrant. So thank you for that comment there. We don't have to worry about the 180 thing because it's just sine x. It's not sine 3x or whatever. But we should get both answers. Okay. All right. So last step here. Okay, so to use the inverse trig function, the equation must be in the form of the arc trig, whatever, like arc sine equals n, or inverse trig function equals n. And then you're trying to find the angle. The n is the angle. Or we're going to get the angle when we do the inverse trig function. Okay? All right. So it says use inverse functions to solve this equation. Find all the solutions. Okay? So what are we going to do first here? All in terms of tangent. Go ahead. So it's all in terms of tangent. So we just have one trig function here.
You combine like terms.
Okay, there's no like terms that combine, but good thought.
Factor.
So now we factor. Okay? So we factor. So think, how would we factor x squared plus 4x plus 4? Be x plus 2, x plus 2. So tan x plus 2 times tan x plus 2. So then we set each factor. Well, since it's the same, it's going to be a double root, a double factor. So we get tan x equals negative 2. Well, we're not going to find that on the unit circle, but tangent can be anything. So if we can't find it on the unit circle, then what do?
The inverse.
Inverse tangent. So use your calculator and see if you can finish it off.
Is it negative 63?
All right, let's see. Okay, negative 63. But now again, we need... okay, so it says we need all of them. All right, so... oh, this is a little tricky. Why am I just adding 180 instead of 360 here?
Because, good question.
Because I haven't explained that yet. So I'm just curious if anybody would know. Why would I add 180 instead of 360?
Is it
Is it
tangent?
because it's in a certain quadrant? No.
Wait, that is actually correct. That is correct. But that's not exactly... okay, we're down to our last minute. It's because tangent has a period of 180. So the same answer is going to repeat every 180 instead of 360. Okay? So then we would add 180 and 180 again until we get every answer between 0 and 360. So negative 63, 116, and 296 would be all the answers between 0 and 360. Now, or to see how I actually have the answer written, negative 63 plus 180n, that actually is another way you could say it, to just in general.